Here we have a small positively charged object of a charge of 4 times 10 to the negative 5 coulombs. It's in a fixed position, i.e. can't move, in outer space. A small sphere with a mass of 1 times 10 to the negative 6 kilograms with another positive charge, 3.0 times 10 to the negative 8 coulombs, is placed 20 centimeters away. What velocity will a small object have when it's 60 centimeters away from the object? So this is very similar to another question we've already tried to solve. It's important again to remember that these are both positively charged, meaning that they will repel. So we have your first positively charged object over here, and then your second one is placed somewhere over here. That original distance is what we're going to call R1. That's 20 centimeters. And then this is eventually going to move so that the new radius, so R2, we'll say is 60 centimeters, and that's a total. We have the masses, and they are equal to 1.0 times 10 to the negative 6 kilograms. So, of course, we don't really need the mass of the first object. The only one that's important to us is the mass of the second object, because the original energy is simply made up of electrical potential, and the final energy is made up of electrical potential plus kinetic. And this means that we can rearrange here and solve for the value of V, which is made up from the kinetic energy. So what we have is K Q1 Q2 over R. In this case, we've called it R1 is equal to K Q1 Q2 over R2 plus 1 over 2 mv squared. Just like in a previous example, I can rearrange this entire question, and what I'm left with is V is equal to the square root, and we'll say K Q1 Q2 over R1 minus K Q1 Q2 over R2 times 2 over M. So by doing this, we have a whole huge equation that we can substitute into. I can, of course, take this part and rewrite it if I would like to read K Q1 Q2 times 1 over R1 minus 1 over R2. All of this multiplied by 2 over M. Either way is fine, just depends on how much substitution you want to do. So to save some space, instead of plugging everything in and solving for it, what you end up with is a velocity of 270 meters per second. So go ahead and try this by plugging in all the values into that equation down the bottom left. Just note, of course, that K is a constant, 9.0 times 10 to the 9 Newton meters squared per Coulomb squared, and you have to convert your radii into meters. So try that and make sure you get 270 meters per second.